How are you today? No, it was intentional. Like, I need you to wake up a little bit. So I know that some of you had a rough night last night, yeah, let's start today. So today I want to talk about the Glamorous Toolkit. Let me introduce myself a little bit. My name is Tudor Girba. I recently founded a company, and among other things, I work in partnership with Elliot Miranda to help other companies adopt Faro. I happen to be a board member of Faro, together with Stefan Dukas, Markus Denker, Esteban Lorenzano, and Sven van Kankenberg. Okay. I'm leading the work on the Moose analysis platform. We recently released a new version. It's pretty cool. And I developed a little method which is called humane assessment. But today I want to talk about the Glamorous Toolkit because all of these projects somehow come together in this. And I really have the pleasure here to work with 4 other teammates. Andrei Kish, he's here. Juraj Kubelka, he's not here, he's in Chile right now. And Alex Cyril, he's also here, and Stefan Reichardt. We work as an engineering team, and we want to build this little project which is called the Glamorous Toolkit. How many of you have heard of the Glamorous Toolkit before? Okay, how many of you have used it? Okay, pretty significant amount. So I won't describe too much what it is. What I tell you is that we've announced the project 2 years ago about, and it started a little earlier than that. And in the last 2 years, we've released a couple of products. So one of them is the Playground and Inspector. Another one was Spotter. And the last one that we've integrated in Faro 5 is the new debugger. So I want to go with you through these tools, but not really as a feature-by-feature type of presentation. I'd rather want to take a step back and say, how do we use these tools? And one of the features that we claim to have in the Glamorous Toolkit is the idea of moldability. So the idea of moldability is that given that your systems are so special, so unique, it should somehow follow that your tools should somewhat fit that uniqueness. And the question is, how do you make that type of an idea practical, economical? And does it have any impact whatsoever? And that's what I want to talk about today. So essentially I'll be talking about and I will be talking about the tools, the relationship that we have with the tools that we use. So sometime in the previous century, there was a philosopher which was called Marshall McLuhan. And he had a very peculiar interest. So what he was concerned with was the effect that the newly introduced, massively introduced TV and radio had onto the American culture. Which was a really funny thing to ask. What do you mean? I mean, there's just some tools. Or what do you mean about the implications? Well, the implications turned out that they were rather deep. And so, at the end, he postulated a little law, him together and a guy named McCulkin. And the law says that we shape our tools, and thereafter, our tools shape us. How many of you have heard of that before? Now, let me convey to you what do I mean by that. So I'll give you a couple of examples. And one of them is that, how many of you have seen slides that look like this? Have you seen those? Right? Now, we know that this is not necessarily the most effective way to bring points over. This is not necessarily the most effective way. But yet, why is this behavior so spread? And it's fascinating. I don't exactly know why, but it's fascinating to look at this correlation. Isn't it fascinating? Again, this does not prove causality, but it does it does raise this is a very interesting coincidence. Now, another thing that I do, okay, this is somewhat, far away from what we are doing on day-to-day business. But another thing that I'm doing, I'm actually going around, and in the last year, I just directly asked this question to about 2,000 technical people. What do you think? Do you agree?
More than that.
Right? So basically, right, people agree to a large extent, and those that don't agree send me these kinds of messages. Right? So we do agree that we read code, like developers read code for a large amount of their time. Now here's my next question. When was the last time you heard developers talk about how they read code? Isn't it a strange question to ask? Because, okay, yeah, sometimes people talk about, oh, let's read it like this or read it like that. But even when people do talk about it, they never question the reading part. Which is fascinating, because reading code is the most manual possible way to extract information out of data. And this is what code is. We should know that, because we live among objects, not among code. And yet we still choose to read, and this is fascinating. Now, but what it means in terms of business, it basically means that we're spending the largest chunk of our development budget on something we never talk about. This is the most significant expense we have as an industry. And it's widespread. It's not related only to Smalltalk. I have queried people from all sorts of different backgrounds and technologies. And so this is a phenomenal thing, I think. And the interesting thing is to note how people behave. But here's the other thing. What do people, let's say you have an SQL database, right, a relational database. What's the first thing, like you have a problem inside a relational database. What's the first thing the developers do when they have a problem in a relational database? They write a query, right? Right? That's first thing is some sort of a select of something, right? Very interesting. There's no difference between the problem of understanding code and the problem of understanding data in the database. The only difference is in our perception. So let's take a step back and look at the interface that we are exposed to regularly when we deal with these problems. So how does a typical SQL tool look like? It's like this. And if you abstract, if you go away out of Smalltalk and say, how is a typical IDE looking like? Do you notice the missing bit? There's no query box. It's fascinating how a missing query box correlates with a certain behavior, isn't it? Now, we might think that we are different, but are we? Right? I don't think so. I don't think that we are pushing that envelope, and I don't think that we are really asking the right question. So, that's a little bit of an evidence to me to say, is this worthwhile investigating? This relationship we have with the tools that we use. So what I want to do now is I want to give you a number of demos, and we'll just go through several scenarios. And then I will let you judge whether this actually enables you to potentially think differently. So, is that okay with you? Yes. No. Is that okay with you? Yes! There you go. What? So, I've always wanted to give a concert. Where's the guitar? No, I have a keyboard only. That's okay. So, the first thing I'll be talking about is how many of you are working with relational databases? Right. Working with. Right. So I have one. I have a Postgres installed here in my system. So what I will do, I'll just open a connection onto it. And because I open a connection to it, and I'm able, so the demos that I've been showing have pre-made pieces such that we can go faster through the different steps. So because this is a connection, I don't just look at it like this. So this is an inspector, right? But because it's a connection, it allows me to enter an SQL. So in this case, I have a database with populations and cities and countries. So what I will do, I will just write a little bit of a select. And what do I get? Well, I get a result set. Okay, so if I get a result set, what's the easiest way to, what's the best way to represent that one? Well, it's a table, right? So if it's a table, it has cities and populations and countries here. Let's say that I'm interested in which are the top cities in terms of population, and how are they distributed throughout the continents, right? Just the top ones. So I could write another query, but that would be boring for a demo. And so I'd rather build a visualization. So one possibility would be I could go now and export it to Excel, or I stay right in my IDE. By the way,
do you mean Excel or CSV?
no, I mean, yeah, whatever, CSV. And then open it in Excel. By the way, does anybody of you remember what the I in the IDE stands for?
Integrated.
Integrated. In other words, it should mean that you shouldn't leave it. Every time you leave the IDE, the I in the IDE has failed you. So, what I'm doing here is I just have a little script. So I'm just opening here are all the models, and these are different data rows over here. And I'll just open a little, using the raw cell in this case. I will be opening a little grapher over here, a bar chart. Here are all the cities that I have, and this is the population. So that's great. Now the question is how, which continent is where. So one possibility, for example, would be to color each bar based on the continent. So now I did that, but because I'm not terrible, I'm just an engineer, so I don't know much about geography. So now I would need a bit of help saying, so what is red? Because I just randomly associated colors to identity. So what is red? So I don't know. So I click on that bar, and that's not a static thing, right? And now I can see red means Asia and blue means South America. So if you step back again, right, that's how an integrated scenario could look like. I didn't leave my IDE. In fact, I used the most basic possible tool I have, which is the combination between a playground and an inspector. And I have accommodated that little need. So okay, that was one thing. You don't have to be impressed, by the way. So next, how many of you have heard of Metacello? Yeah, I'll say, oh, Metacello is a very cool project, right? It's cross-dialect, and it helps us, deal with large projects. So thanks, Dave. So now, one thing though with Metacello is that once you start to maintain it, it takes a little bit of a skill, and I don't have that skill. And so what I would like now to do is I would like to find out the information about how is the configuration of Glamorous Toolkit, how is this organized? Is this really up to date or not? So, but I don't know exactly how to do that. So what I will do now is I will go to Slack, and I have my teammate here, and I say, hi Andre, would you know how to obtain all dependencies from Metacello? Because you see, I've looked actually Metacello to actually get all the transitive, all the recursive things in terms of just the project that we have there, and all the be able to draw those edges in between that. Oh yeah, look at this guy. So he's pretty cool. So he sends me a link. Okay, that's cool. So I'll copy that link and I go back, and because I have here this spotter thing, I just paste that link, right? And I have the code. Again, you don't have to be impressed. So what this happened here, what he sent me, is a little script using something called Deep Traverse. Deep Traverse is a tiny little engine that just allows you to traverse any random object by providing here the traversal that you want to use. And in this case, we just want to collect everything. So basically, if I do that, it should give me, okay, in this case, configuration of moose. And we have here all the this case, 49 different subcomponents. That's different kinds of configurations in there. So what I want to do now is I want to take these things and I says, okay, I'll put them in a variable. And then I'll say, well, maybe I want to create a view, because I just want to understand how deep those things are. So I'll create that view. Let's see if I now execute that. I have now the 49 different dots over here. So maybe I'll use a grid layout, and that's fine as they're there. Now these are not dead elements, right? This is live, so this is an actual configuration. So the configuration here knows, for example, what projects it has. So what I will do quickly is I'll say, okay, I want to create some edges, and I want to connect each of these elements from itself to all, and then I'll use the same magic thing that Andre gave me. So now if I execute this one, then I get the edges there, and let's push back edges, and maybe I should use a different layout. So let's say horizontal tree layouts, and then maybe I want to use it as layered. So now if I'm executing that little thing, okay, horizontal tree, that's better. So now I have that dependencies over there, right? Wait, it's not yet the time. So now we have, we want to say, let's put we can go and evaluate these ones. And now, isn't this an interesting thing to have when we're just, evaluating this? So when I'm inspecting the configuration, now I don't want to build this thing again, right? I want to utilize it because I've already built it, so I want to use that knowledge. And so what would be cool would be to go and add a new thing over here. So let's do that. And now it happens that I've already created that thing, and I'll just annotate it, right? It's the same script with a little bit of enhancements. So now I have here a project map. So if I now switch to the project map when I'm inspecting a configuration, I have the configuration. And that's how now we can scale. So when you're, for example, one of the things we did was to, when we're releasing this whole thing, 49 packages, the problem is, because we need to do recursively release, but not all of them, just some of them. So then you need to still be able to evaluate, and there is still a little bit of a manual step just to ensure that you actually have released all the interesting pieces and not because it's not completely automatable. So what we actually do is we compare the pictures from before and after, just to say where is the difference, and we can highlight those on the same map. Right, and then we say these are the pieces that did not change, and if they did not change, then I can focus on them. So in any case, and now we can click on that, right? Now I can find, for example, all the packages. Right? And again, this is how we can work on things. Now, sometimes, every now and then, sometimes you have a problem and you want to search for things. So you want to search where exactly is the GT inspector, where exactly is where exactly is the moose finder package? And then you can say, well, it's here. So now I just connected the spotter with that specific object, and now I have a contextual search right there. So now you can read it. Okay, but now. But more interesting is when you actually start to use those things for doing real work. So I have prepared here a little, I reproduced a little bug we had a while ago. And this bug looked like this. So when I got a debugger, I could debug and everything's fine. So this is a new GT debugger, the default view of it. So now, because when I'm in a class, I can say, okay, I want to get the implementers. Well, look what happens when I get the implementers. I get two windows. Right? So that's not a most terrible bug, but it's incredibly annoying. So we want to fix that thing. But now the question is, how do we do that? So let's go and think through it. Okay? So obviously, the method that spawns the window is being called twice, right? So we should go and find that place. So let's find it. Now we know, if you're remotely familiar with the code model with the code model, then you know that these are basically very quickly you get to browse messages. This is one of the this is the message that basically is being sent. So browse messages will open that implementer. So now basically here it's probably here this one is being called twice. So what can we do? We can put, for example, a halt. Okay, now we actually could use the cool new thing, and that's to put a breakpoint, right? That's a really cool thing that Marcus has worked on, and it's very nice, right? So you have this beautiful integration directly in Nautilus. So, which means that now if I do this again, I should get my thing twice. So let's do this. So implementers, oh yeah, there is a break. So let's debug that. Okay, it looks like this. So it comes from here, performing, there's an execute action, there's an sglamour action, and so on. Okay, let's proceed. I should get another one. I did. And there's a browse message that's performed, there's an execute and sglamour. Well, it looks very similar to me. So how do I debug that? Because there's no real difference. They don't seem to come from different places, which is fascinating. So I don't know exactly what to do. Well, except I do know what to do. And what I do in this case, I will remove the breakpoint, and I will insert a little log statement, right? How many of you are using log statements for debugging purposes? Right, I use also log statements. I just hate the strings. So I will use a different kind of a thing, and this is called a beacon BNG. So I want to tell beacon, could you please log the stack? Okay, just that. And I will start now an in-memory logger so that it can capture these ones. And I will reproduce the bug again. So now I'm debugging, and I'll say, well, find me the implementers. And those things have popped up. And I'll go back, and now I will take a look at the log. Now, sure enough, I have two stacks, right? So stack number one, if I'm executing that, if I'm looking at it, I can say, well, here's the stack. Okay, so if I click on the stack, then I can get the source code. So this is not a debugger, this is an inspector. And but if I look at the other one, right? If I take a look at the other stack, it's remarkably similar. There is no difference between them. So I'm a little bit stuck, because what it basically means is that, so if this one shows me source code, so likely the problem comes from different receivers, right? So at some point, there are two things maybe are in some sort of a collection, and they are twice coming in. So, the only possible way would be to somehow do some sort of a conjunction between these two stacks. I have two stacks now, and somehow I want to visualize when are they different, or are they different at all, or do they share anything in common? So I have a little script over here. So I will first just collect the stack. So these are now some logging elements. I'll just collect the stack. So I have 63 items in both of those stacks, right? And what I will do now is I will again use Russell. And in this case, I will take all of the 63 from the first collection, and all of the 63 from the second collection, and I will put them in a set so that, like this, if they are duplications, they will be removed. And then I will draw edges between any subsequent stacks, right? So from a context to the previous context. So when I execute that one, I expect to get either 2 lines, or maybe there's going to be a tree or something, or maybe there's going to be a merge. I don't know exactly. So let's take a look. So it looks here like that these are now this is a stack. So if I click on that, let's get a source code over here. So these are now linear things calling from one another. Now notice here what happens. There is a branch, right? Now this branch is induced, obviously, by a receiver. There's two different kinds of receivers there. Something is wrong there. So let's click on that, let's see what that is. And this is a deliver thing, deliver to something in subscription registry. So now we know that this is part of announcements. Now if this is part of announcement, it basically means, well, let's take a look. Because this is the delivery method of announcements. So let's take a look. What are the registered receivers there? So the receiver is a subscription registry, right? And the subscription registry knows the subscriptions. So do you notice something? So there are duplications in the registrations of those things, right? In the subscription registry. Now I won't go into the details, but basically, essentially what happened there was that we mistakenly somebody put another registration in the wrong place, and you wouldn't have seen it. You can't see it with the property debugger because it's not the difference is not in the stack. The difference is in the objects. So the only possible way to look at this is to look at the difference between objects. Now, who thinks this is a little bit like whoa, whoa, whoa? Right? Who thinks it's like it's just very, very deep somewhere there? But look at it from a different perspective. We have just built, who understood not the details, but just the idea of what I'm showing. So this is not so foreign, isn't it? But what we have just built was a debugger specifically for our problem. And afterwards, we will throw this whole debugger away, like this. Boom, it's gone. Right? We solve the problem and we throw it away. Just a second. Yes, Steph.
But you see, so this means that maybe you should have a debugger that you can script.
Yes, maybe you should have a debugger that you can script. Yeah, exactly. All of those things are open. That's what we're saying. Exactly those types of ideas. We need to dream way bigger than when we are right now, because those tools have imprinted a set of patterns, behavior pattern onto us, which are not necessarily the best kinds of behavior patterns we can have. The options are immense, but we have to look at them. Now here's the interesting thing. So I think Serge was looking at exactly this problem in parallel by mistake. Right? They were at a sprint and they were a pair and they worked for 2 hours, I think, 1 or 2 hours, I forgot what it was, and they couldn't fix the bug. So this exercise, the complete exercise, in my case, it took 15 minutes. Of course, well, it's not fair because there's much more exercise in working than this. But the point is that I would have not been able to solve it myself without the tools. It is not the person that is doing it, it's the tools and the way to think with those tools. Okay, so one of the things, for example, that came with Spotter was this ability, for example, not just only to search for, to do quick searches, right? Very, very quick, simple searches, because the quick searches that I did before were very deep and detailed. So now we go quickly up. And so one of the things that we do, all of these extensions that you have are being added to the system via pragmas. So basically you can do something like this, so like Spotter. There is something with Spotter in the pragma, so now I can scope the search just for that, right? And then I have the Spotter, and now I'm looking at all the usages of the Spotter order, right? I don't have to have a different thing. So for example, now if I want to refine the search, now I have a simple search. So that's another way of thinking about this. And now all of these Spotter searches are also extensible, right? So people can build their own Spotter searches. And there was a long debate as to, is this useful or is it not useful? And we'll come back to this a little bit later. But the point is that if you can't predict the specifics of the needs, you also cannot give hard-coded set of direct functionalities. If problems are so unique then that they are not repeatable, then all of this extensibility must be available and very cheap to produce. So one of the new things that we have added in Faro 5 is the debugger. So in the debugger, for example, we have we have, you have the standard debugger, but you can also have custom kinds of debuggers. So here I have a Seaside application. Just the standard to-do list. How many of you know the standard to-do list? Right. Okay, if you don't know it, it's just a standard to-do list. So what I would do now is I would just try to say a new task, right? And I'm trying to edit, but it doesn't work. So why does it not work? And of course, well, I have a debugger. So now what's the first thing you do when you get, or let's say among the top things that you do when you have a problem like this? So first, you get a debugger, so you have no idea, why do I get that debugger? So the first thing you want to do is you want to get, what's the request that came into the image, right? So at this point, I should now go through the stack. You notice what I'm doing? I'm scrolling through code. Now, how long is this stack? I don't know, but I'm scrolling through it with my best intentions. So I'm actually looking for a context. The next thing, so I don't know exactly what it is. So I'm sure that if I look closely here, I will find that thing. But it's hard to get. Oh, there's a render context, but it's not what we're looking for. But there's a request context. So it's somewhere like the 5th page down. There's a request context, and basically it says that this is examples to do, and this is the request, right? That was the URL. The second thing you want to do is you want to maybe know, if you're using, for example, component nesting, you want to know what kind of components are there. So here's a to-do item, right? This is what's a to-do item, and we know, well, I don't know this is a component, but I guess it is. And somewhere, this one is embedded into another one, but I don't know where. So I don't know how long I should scroll now. It's very tedious for me to go and scroll through all of these. So that's why, because the stack now has Seaside-specific things in it, we can ship a specific debugger that understands those specific things. So if I now switch to the Seaside thing, so this is a new debugger that Andrei Kish created in the last 2 days. We now have a couple of new information. So first of all, we have here, okay, here's the request context. This is what you're looking for all the time. Here's the request context. Okay, I don't have to dig through the stack because this is what computers are good for. Or here's the nesting context. Okay, these are the components that are around. Or maybe if you're interested, say, okay, but these are components, they're objects, but I'm actually interested in where are they in the stack, so why are we not filtering that, right? So now we have the to-do item where all these components appear on the stack. We're just showing those frames, and that's it. And then basically, here's the bug that we just manually introduced. So these are routine things, right? Now, how did we do it? Well, we are not Seaside specialists, so we just asked. Okay, we asked this week, what kind of problems do you have when you have Seaside? We got a couple of inputs, says, okay, this is a type of problem, this is a type of problem, and we started on Wednesday, well, he started on Wednesday, I'm just the one that is talking. He started on Wednesday, and we just iterated a couple of times over it. And then this morning we added this component stack because it just looked like a very interesting thing to have. So now again, is this the perfect Seaside debugger? We don't know. But the point is, it should not take enormous amount of time for you to find out whatever works for you. And that is the difference in thinking. You don't have to comply to tools. You can make the tools comply to you. And the same thing we can do with other kinds of things. So here I have a petit parser. Let's say if I'm debugging this one, I could just go into it, but it's very, very painful. So I'll just say, or here's the petit parser debugger. The petit parser debugger says, okay, here's the stream. So I can run to the next update of that stream. Or you can click somewhere and it says, could you run up to here? Or you can say, could you please go to the next production in the parser? And when you're looking at the parser, you're looking at it like this, right? Because this is what you wrote. So this is how we are debugging the petit parser runtime. Now, interesting thing here is that, again, we have created this one, so it's maybe not so fair. So what we have done, we have convinced John Brack, who said, well, look, you're building a parser framework. It's Mac. It's an amazing parser framework. And said, well, here's what we have done with petit parser. And I said, well, that is kind of interesting. So it took him, like a week to move to Faro because, he was not in Faro. Actually, not a week, but. And then another week he came back and he said, "Well, look, I have something." And they said, "Okay, so what do you have?" So here's, for example, a JavaScript parser, and there's an error somewhere in the JavaScript. So, well, this is what you do here. You have all these things, tables that you need to compose in your brain. And this is what he created. And now he has all these different things that you're having there. This is the look ahead. These are the different symbols that can possibly match. This is, step to the cursor. You can do it like this over there. You can't because here. You can go through the action. So you have these specific kinds of behaviors. And now this is how he's building his phenomenal parsers in helping people move from one technology to another, as if it would be the most easiest thing of them all, right? Now he has done this for more than a decade, right? Maybe 2 decades, and he still finds this one better. So I don't know about you, but what do you think? There was a lot to digest, I understand that. So one thing, as a last thing, we've done a little project this year. This was done with Lam Research Corporation, and that was a very exciting project for us, right? So I worked with Elliot, and we tried to, introduce some of these techniques into the world of Lam. And what I would like to do is I would like to now ask Chris to say a couple of words about how he perceives that this worked from his point of view.
Introduce Chris.
Oh, I'll introduce myself.
Chris knows who he is.
I do, yeah. Wow. Okay, so I thought you were going to have some slides, but I'm going to try to verbally communicate what happened. So, as you said, there was a project with Lam. For those of you, I'll start with me. My name's Chris Thorgrimson. I'm a technical director for Software and Controls Group, and we use Smalltalk every day. What we make, for those of you who, by a show of hands, does anybody know who Lam Research is? Okay, so not bad. You guys have heard this spiel before. So I'll just quickly explain. Lam Research, we make semiconductor capital equipment. So we make the equipment that is used to make integrated circuits. So by a show of hands, who has a smartphone? Probably everybody. Laptop, television, whatever, right? If you own a piece of electronics, our equipment was used to make that piece of electronics. So whatever's in your smartphone, whatever is in your camera, that projector, this screen in front of me, our equipment was used to make that. And Smalltalk plays an important role in that. We're a commercial Smalltalk user, so we use Simcom VisualWorks. And we wanted to sort of expand our ecosystem. So we wanted to kind of, see, we've always seen Faro, and we've seen the different dialects of Smalltalk. But we decided that, this year was going to be our year to investigate Faro. And so we figured we should engage with the 2 kings of Faro. Faro is a whole community of kings. But Elliot and Doru, on recommendation from Steph, where are you, Steph, was, who we decided to engage with. We took a component that is normally a component that is considered sort of off limits. It's a very complex piece of our software, and we gave it to Elliot and Doru, and oh, there it is, okay. See, I knew there were going to be some pictures. And the idea was, we gave them the component, and we said, okay, this part, we want you to move this part to Faro. And if you can do it, then it's an indication that we can actually start using Faro in some of our day-to-day. I gave it to them, and I was waiting for okay, we're going to need some of your time to explain what the heck this thing does, and we don't understand it. But about 4 weeks later, I got the email saying we're ready to give you a demo. And that part right there was the part that we really were impressed with, was that I didn't hear from them for about 4 weeks, and then the next time I heard
We
from
were on
them...
holiday, right?
Yeah, she went to... don't tell me that now. But yeah,
The ghosts were good.
So we had this really complex piece, and they were able to move it to Pharaoh and to actually get it to work. And so we actually we're like, yeah, I don't really care now. What we really want to know is how the heck did you guys do it in such a short period of time? And so that's when Doru explained to us the methodology that was taken. And that actually was a side benefit of the project, was that we were fascinated by the methodology that they used. And we wanted to know a little bit more about what you guys actually did. And so, you know, that was the story, the takeaway, was that the humane assessment method was a technique that was used to take a piece of code, and they didn't read code, they reasoned about the code using the methodology. And so we wanted to know, okay, how can we apply that in some of our day-to-day? So Doru came to LAM for about a week, and by the time he left, we had Petit Parser integrated, and then we started building tools on top of Rosal to help us also reason about our code, the structure of our code, the structure of our equipment, and we didn't look at code anymore. So we've got a little bit of momentum going on where we're starting to use tools that are integrated now into VisualWorks to take some of the things that you guys are doing in Pharaoh and to help us with our day-to-day. But I can definitely say that we're a believer in the humane assessment method. So.
What I would like to emphasize here is that it's not the people that are doing it, because when you're thinking in this way, right, when you're approaching problems like that, we think that there is a whole new potential of working. And especially in a small environment, this is just the perfect place to apply these types of thinking. And so what the Glamorous Toolkit does, so in this case you see, right here you see the class hierarchy of the project, and we have migrated them, you know, there were problems when migrating things, and the red parts are, this is an inverse cluster kind of visualization, so the root is in the middle and the leaves are on the outskirts, and the red things are the to-do lists, right, those things that have problems. And then you can explore them to the right, you can look in the source code and so on. This is the inspector, right, but the inspector became our browser of code, and so this is how, for a month, this is how our progress bar looks like. I don't know how your progress bar looked like, but this is how ours did. So, and this is an opportunity, right? I would like to invite you to look at these tools not as a mirror of what existed there before, but as a new type of an opportunity. So, and again, we just looked at briefly at a couple of the things that we have seen. So this is what you see publicly from the Glamorous Toolkit project. So the playground, the inspector, spotter, and debugger. But there is a whole lot more going somewhat behind the scenes. So you saw there's a little bit doing in querying, so with Deep Traverser. Beacon started inside the Glamorous Toolkit project and now is being carried through by Dennis and by Norbert. So, and that hopefully will maybe become a different, more mature logging framework than just things that are being done right now. And there was a couple of other things. So you'll hear about block tomorrow. It's a new kind of rendering which we think is needed in order to express some of the things that we cannot express right now from a graphical point of view. But one thing, like we said from the beginning, is that, well, is this really, because I gave you a couple of examples, or a handful of examples. But the question is this really widespread? Does this need exist truly on a widespread scale? And now, we don't know, right? So here's a map of Pharaoh. Okay, it's actually not just Pharaoh, and this is the whole moose and a couple of other things inside. So it's about twice the size of Pharaoh. And here are the classes. So what you're seeing here, you're seeing nesting, and the gray bubbles are the classes. And these are the classes that have at least one extension. So we're talking about 431 extensions inside this image. Okay, this is a regular image that you get basically when you're downloading the moose image. And the average extension there is 9 lines of code. But now these, because in Smalltalk we have inheritance, well, whenever you're defining something on a superclass, you'll get those extensions on the subclasses. And if you take those into account, the picture becomes like this. This is how widespread that need is.
Can you go back to the fourth previous year?
So, What does it mean? Well, it basically means we're talking about 25% of the classes and touching 96% of the packages. That is how widespread that particular need is. Now, when you have something like this, you will find out a very interesting phenomenon, and that is that most of these extensions are not useful for most people. But that does not mean that they are not useful, because when context is important, you will see this behavior all the time. Right? For example, most phone apps are not useful for most people. It doesn't mean that the phone apps are not useful. So that was a little bit of a brief overview of what the Glamorous Toolkit is, and with the little hint of where the philosophy is coming from, and we're going to keep going towards that path. So one thing, I was here 2 years ago when we announced the Glamorous Toolkit first, and at that time I said, well, I don't want to wait another 20 years to produce something like this. Now, as was mentioned in the previous talk, Smalltalk did take 10 years to get refined. Now we are in our second year. And I think there is a whole lot of potential there. So we start from that team, but we don't want to stop there. We want to engage the whole community. Now I know that sometimes we look like we are just working on it by ourselves, but this is not really what we want to do. What we want to do is just try to bring up the conversation in a slightly different direction than it would go if we wouldn't reconsider the situation. And I would like to welcome you if you'd like to join our effort. And I want to wish you a pleasant conference. Thank you very much.